Can you see the screen?
Yes, ma'am.
Okay, all right. So we have done this till here. Okay. So
Okay.
this is exactly what we concluded on much more direct grounds, and that is we have done this relation, this one.
Yes,
We're
ma'am.
done in faction 7.11, 7.1.1. And now we have the next topic, momentum. What is it? And we learn here Newton's third law in electrodynamics. So here now imagine a point charge q that's traveling in along the x-axis at a constant speed v. Because it is moving and its electric field is not given by Coulomb's law. Nevertheless, Nevertheless, E is still pointing readily outward from the instantaneous position of charge. As we'll see in chapter 10 further, and since moreover a moving point charge do not constitute a steady current,
Okay, ma'am.
its magnetic field is not given by Biot-Savart law. And nevertheless, in fact, that we still circle around the axis, manner suggests that right hand rule. And again, the proof will come in next chapter. So now let
Okay, ma'am.
us see. Figure 8.2, and we see here A and B. Now suppose this charge encounter an identical one proceeding in at the same speed along y-axis. Of course,
Yes,
the
ma'am.
electromagnetic force between them would tend to drive them off the axis. But let us assume that they are mounted on tracks or something. So they are applied to maintain the same direction and same
Okay,
speed
ma'am.
as in figure 8.3. We'll see the electric force between them is repulsive. But how the magnetic force? Well, let's see. Well, magnetic field of Q1 points into phase at the
Okay,
position
ma'am.
of Q2. So the magnetic force on Q2 is toward the right, whereas the magnetic field of Q2 is out of the phase at the position of Q1. And the magnetic force on Q1 is upward. And the net electromagnetic force of Q1 and on Q2 is equal to but not opposite of to the force of Q2 on Q1. We'll see next
Yes, ma'am.
figure. In violation of Newton's third law, electrostatic and magnetostatic third law hold, but in electrodynamic it does not.
Okay, ma'am.
See, means they are talking about here in this para that charges Q1, Q2 are moving, and then
Yes, ma'am.
let us see the direction of the both field. See, we can see
Yes,
here
ma'am.
Q1 and Q2. Okay. And Q1 is moving like along x-axis while Q2 along y-axis. And here we these sorry relationship between like B direction of B, FM and FE and similarly on charge Q1, V2, FE, FM will
Okay,
work
ma'am.
according to some rule. You know, do you
Yes,
remember
ma'am.
that?
Yes, ma'am.
Your voice is very slow. It is audible, but not much clear. So it's okay if you can hear me.
Ma'am, I can hear you.
Now I can hear you also clearly. And the time
Okay.
your voice was very slow. Okay. So momentum conservation is rescue in electrodynamic. Maybe realization that field themselves carry momentum, and that is not so surprising when you consider that we have already attributed energy to the field. Whatever
Okay, ma'am.
momentum is lost to the particles is gained by the field. Only when the field momentum is added to the mechanical momentum is constant. conservation, restore. Mean conclusion is that when momentum is lost on the particles when they are moving
Okay.
and can gained by the field.
Okay, ma'am.
And only when the field momentum is added to the mechanical momentum is momentum conservation score. Now, let us learn Maxwell's stress tensor and let us calculate total electromagnetic force on the charge in volume U. And it can be expressed as F is equal to volume integration of E plus V cross V into rho. That is equal to, and we have done this already in previous chapters. And
Yes,
volume
ma'am.
integration it can be expressed as rho into E plus J into V. Means volume integration of rho into E plus J into V. The force per unit volume is F is equal to rho into E plus J into V.
Okay, ma'am.
As before, I propose to express this in the term of field alone, eliminating rho and J by using Maxwell's equation, first and second, first and fourth, sorry, and F can be expressed as F is equal to epsilon 0 divergence of V into E
Okay.
plus 1 upon mu 0 into curl of V
Okay.
minus epsilon del E over del T into uh, sorry cross B, and we can express the del over del T of E cross B is equal to del E over del T into cross B plus E cross del B over del T. And Faraday's law says that del B over del T is equal to negative curl of E. Now we
Yes,
can
ma'am.
substitute del E over del T cross B is equal to del over del T E cross B plus E cross del cross of E. And thus we can express this app now by using above equation. So F is equal to epsilon 0 vacuum del dot E into E minus E cross del cross minus 1 upon mu 0 B cross delta cross B means of you can say curl of B minus epsilon 0 del over del T E cross B. And just to
Okay,
make the
ma'am.
thing look more symmetrical, let us show in term delta dot B into B. Since delta means divergence of B is equal to 0, so this cost us nothing. Meanwhile, product rule 4 says that divergence of E square is equal to 2E into dot delta into E plus 2E cross curl of E. We can express it as or we can write it as E cross curl of E is equal to half of the divergence of E square minus E dot delta into E. Now same goes with B also. So we can express B also in the same manner. And so we have now equation that of F. So this equation F can be expressed as now F is equal to epsilon 0 and into divergence of E into E plus E dot delta dot E plus 1 upon mu 0 into divergence of B into B plus B dot delta B and minus
Okay,
half
ma'am.
of delta epsilon 0 into E square plus 1 upon mu 0 B square and minus epsilon 0 and del over del T and E cross B. We have as 8.16. Agree, but it can be simplified by introducing Maxwell's stress tensor and Tij is equal to epsilon 0 into Ei into Eg
Okay,
minus
ma'am.
1 by 2 del Ij E square and plus 1 upon mu 0 Bi into Bj minus half of del Ij B square. equation
Okay.
8.17. And indices I and j refer to the coordinates x, y, and z. So the tensor has a total 9 components. We have t x x t y y t x z t y x and so on. We have like y t y z t z z, like we have 9 components like this.
Okay, ma'am.
So now the Kronberg delta del Ig is 1 if indices are the same. If they are the same, then its value is 1 and 0 otherwise. All other are 0. First, Txx can be expressed as half of epsilon ex square minus ey
Okay, ma'am.
square minus ez plus 1 upon 2 mu 0 and bx square minus by square minus b that is square. And txy can be expressed as epsilon 0 exay plus 1 upon mu 0 bxy. Because for different, for different indices, tail
Yes, ma'am.
value data 0. That is why we have in this. And so on. We can find in same way other components because
Okay,
it
ma'am.
carries two indices when a vector has only one, and Tij in some time written with a double arrow like this. And one can be from the dot product of G arrow with a vector A in two ways on the left and right, we can see. And dot A dot G is a Tj is equal to summation I is equal to x y z ai into Tij.
Okay, ma'am.
T dot A is equal to I is equal to x y z into T j I into I.
Okay, ma'am.
So what are they? These values of t x x, t x y, t y z, they are mean all 9 components are mm, components of stress tensor. You know, they told us in below, just below the equation 8.17,
Yes, ma'am.
they are the components of stress tensor. The resulting object which has one remaining index itself a vector. In particular, the divergence of T has its J component. So delta T or divergence of T can be expressed as epsilon 0
Okay, ma'am.
means divergence of E into Ej plus E dot delta into E minus half of delta J B square and plus means divergence of this stress tensor can be expressed as plus 1
Okay,
upon
ma'am.
music bracket divergence of B into Bj plus B dot delta into Bj minus 1 by 2 delta J B square. And thus the force per unit volume of equation 8.16 can be written in the much tighter form. F is equal to divergence of T minus epsilon 0 into mu 0 del S over del T. And where S is the pointing vector as we have done in equation 8.10.
Okay, ma'am.
So now the total electromagnetic force on the charges in nu, where this nu is the volume of enclosed surface. Yeah, that yeah. As in beginning they have expressed nu is volume. So the total
Yes, ma'am.
electromagnetic force on the charges in nu, that is equal to F is equal to surface integration of T and minus epsilon 0 mu 0 and derivative of surface integral, sorry, volume integral of S.
Okay,
And
ma'am.
here I use the divergence theorem to convert the first term to the surface integral. In the static case, second term drop out and the electromagnetic force on the charge configuration can be expressed entirely in the term of stress tensor at the boundary.
Okay.
Means on a boundary condition, they are saying that second term drop out. In static case, the second term drops out in equation 8.00, and we are taking only this F can be expressed in the term of stress tensor at the boundary, okay, and in static. So
Okay, ma'am.
physically, T is the force per unit area here, or stress, you can say. T is force per
Okay.
unit area, or you can say stress acting on the surface. More precisely, Tij is the force per unit area. In the ith direction, acting on the element of surface oriented in the jth direction. In diagonal elements, these components of tensor represent the pressure, and off diagonal elements means same. Having the both suffix same means they are diagonal elements, and all other off diagonal elements are shears.
Okay,
Are
ma'am.
you getting this point?
Yes,
Means
ma'am.
further we'll do, if we need to find pressure, then we'll use these three: T X X, T Y Y, T Z Z, and off diagonal elements are shears.
Okay, ma'am.
So let us see this example. Okay, it will take time. So shall we do tomorrow
Yes, ma'am.
this example? Okay. So we'll start from here tomorrow with
Okay,
example
ma'am.
8. Okay.